Hi, once again, everyone. We are on page 52 of our statistics class notes, and we're in section 4.2, talking about the correlation coefficient for linear regression. So just some important notes about the correlation coefficient. If we change the order, in other words, switch x and y, and one time you call one variable x and next time you call it y, that will never change actually what r is. All right, it certainly will change what the regression line is because your scatter plot will look different if you switch them too. But it won't change how strong the relationship is between the two variables, which we measure through the correlation coefficient r. If we add a constant or multiply by a positive constant, any of our variables, it does not affect r either. R is unitless. It does not have units associated with it. It's just a number between -1 and 1 that tells us how strong the relationship is. Close to 1 or -1, it's a strong relationship. Close to 0, it's a weak relationship. R is only useful, though, for measuring a linear trend. One of the things that even people who are really good with statistics forget is to make sure they look at a scatter plot first and make sure that we actually look like we have a line that could pass through our scatter plot, not some other kind of trend. So we always have to make sure we're measuring a linear trend, not another kind of trend. In this class, we will only do linear trends, but you need to guard against whether your data is linear or not. Always graph your data first. That's what I was just trying to point out. So let's do an example, a matching example. Let's say I asked you to match the correlation coefficients below, which you can't see in this window yet, but you can see on your blank notes, to the correct graph. And before I actually look at the correlation coefficients, in my mind, as I'm looking at it, I can see that graphs A, B, and C all look like they're positive correlations uphill. D looks like it's the only negative correlation downhill. And if I'm looking at A, B, and C, which one's the strongest? It looks like B is the strongest, and then C, right? And then D is, or A, excuse me, is the weakest. Okay, so again, I'm saying strong because I'm looking at the vertical variation or the spread away from the imaginary line I'm putting through there vertically from this imaginary line. Strongest, strong but not, not as strong but not weak yet, and then sort of a weak correlation here. So that means that if I look for my strongest positive correlation, that's R.885, that would go with B because it's the strongest. My second strongest positive correlation, 0.724, would go with C because it was the second strongest positive. There's my one negative correlation, so that goes with D. And then my weakest positive correlation goes again with A.